Well, all right, everyone. It's day 3 on Unit 8. I don't know if you can see me or not, but hello if you can. I just wanted to teach you guys how to do the graphing of these rational functions by hand. I've got the calculator pulled up so you can check your work, but there's a section on the SAT that is no calculator, and that's where this section is found. So I wanted to take a few minutes and put everything together that we have done so far. The things that we have done up until this point have been vertical asymptotes, horizontal asymptotes, x and y intercepts. And that's all I need to be able to graph these guys. Okay, so first thing I want to do is calculate some of these things. I need to find my asymptotes and intercepts first. I'm going to start with my vertical asymptote, my VA. Remember, it is the restricted value out of the domain. So if I say x plus 1 is equal to 0, then I can very quickly find out what the restricted value is. So the vertical asymptote is x equals -1. So what that means is I can be anything I want to in the whole wide world in this graph, but I can never be a -1. So that's the first thing I put up here is the vertical asymptote, and it is x equals -1. It cannot touch that point. Well, my calculator decided to go away. Oh well, we'll look for it in a few minutes when we get ready to check our work. All right, so there's our vertical asymptote. The next one that I want is called the horizontal asymptote. And remember, that's when I analyze top degree versus bottom degree. So when I look back and I see that I have a 3 on top, and then I have an x plus 1 in the denominator, my degree of the top, so my top degree, since it's a constant and it has no variables, is 0. And my bottom degree, since I have an x to the first power, is 1. And so since the top degree is smaller than the bottom degree, then I have a y equals 0 as my horizontal asymptote automatically. There's nothing else I need to calculate. So I'm going to switch back to a red because that's an asymptote, meaning the graph is going to get closer and closer to it but never touch it. So y equals 0 is a horizontal line. That's why it's called a horizontal asymptote, where y is equal to 0, and I'm going to call this y equals 0. Now the graph is going to be in between those asymptotes somewhere. So we want to find out where it is. So the easiest thing for me to do is to find out what are the x and y intercepts. Okay, so the first thing I'm going to go for the easiest one because I think the y-intercept is actually the easiest one. The y-intercept is when I let x equal 0 and solve for y. Okay, so what I'm going to do is I'm going to go back and I have f of x is equal to 3 over x plus 1. Remember that f of x just stands for a y. It's the name of the function. So I'm going to say y is equal to 3 over 0 plus 1. And I have a 3 over a 1. So therefore, my y-intercept, when my x is 0, my y is 3. So I'm going to go to a 0, 1, 2, 3, and I'm going to make a point. It is really that easy. Now, the next thing I want to find is the x-intercept. So the x-intercept, and if I'm paying attention, I notice that my y equals 0 is part of my asymptote, meaning that my graph is never going to touch the x-axis. However, I can verify that just by doing our standard procedures for calculating an x-intercept. So for x-intercept, I need to let y equal 0 and solve it for x. Or we can remember the shortcut that if we set the numerator equal to 0, that 3 is not equal to 0, and so therefore it does not exist. And we call that a D in E. It does not exist. Okay, so when I get ready to look for my graph, I have 1 point of the graph already, and I need to find a couple more. So the way that I'm going to tell you to find your other coordinates on the graph is I'm going to tell you to make an XY chart. I'm going to tell you to go back and find out your excluded value from your domain. And x cannot be -1. That's my vertical asymptote. I cannot ever touch that point. So -1 is an excluded value because that's my vertical asymptote. So I put that in the middle, and then I choose 3 values above -1 and 3 values below -1. So I'll go -1, 0, 1, 2. That's the 3 above. And then I'll do 3 below, -2, -3, and -4. So it's not 5 below. I think that's a store, right? It's 3 above and 3 below. All right, now really quickly, in order for me to find out what the other points are, my equation was this: 3 over x plus 1, and in place of x, I'm going to put a 2. So what I have is a 3 over a 3, which means that 2, 1 is a point on that graph. So I'm going to go not from the intercepts of the vertical and the horizontal. I'm going to go from the original, from the origin. So I'm going to go over from here. I'm going to go over 2 and up 1. Well, that's perfect. Now let me calculate the other one, because you see I already knew that 0, 3 was an intercept, so I don't have to calculate that again. I only need to calculate one more here. So I have 3, and then I'm going to put 1 plus 1. And so what I end up with is 3 over 2. And if you use your calculator, 3 over 2 is 1.5. So I need to go from the origin over 1, up 1.5. And then I'm going to make this look a little rounded. This is what the graph looks like. There's one of the branches. Now, I allow you to use your brains a little bit and not have to do so much calculation, as long as you know this: if this part of the branch is in the first quadrant, and the other part is going to be in the third quadrant, it's going to be exactly opposite of it. And here's what I like for you to do. If this is at 0, 1, 2, 3, then I know that if I move in to the inside of this, then I bet you I have a point that's exactly opposite of it on the other side. So you see, this is from the asymptote. I went over 1 and up 1, 2, 3. So if I go over 1 and down 1, 2, 3, I bet you I'm going to have another point. Just to confirm that, before I go any farther, let's go to see if we can do some substitutions. So if I have 3 over -2 plus 1, I end up with a 3 and a -1, which means my point would be -2, 1, 2, 3. There it is. I was right. But you don't have to do that. You are more than welcome to calculate these. There's a 3 over -3 plus 1. And so I end up with a 3 over a -2, which makes this a -1.5. So I'm going to go 1, 2, 3, 1.5. And then the next one is -4. So 3 over -4 plus 1 is going to be a 3 over a -3, which is a -1. So 1, 2, 3, 4, -1. And then if you look, voila, we have the graph of a rational function. Now, I'm going to give a quick try to pull up this calculator here. I haven't had much luck. Here it comes. While it's in this position. But at any rate, so here's what we're going to type in. We're going to take 3 and divide it by, we had an x plus 1. And then I'm going to hit graph and cross my fingers that it's going to look exactly like what we just had. So it does indeed. It does cross over. If you'll look at this, it does cross over the y-axis just a little bit, because my asymptote is at x equals -1. And since this is a function graphing calculator, it won't graph a vertical line. But you are more than welcome to use your calculators to check your graphs. And that's fabulous. I love this stuff. All right, let's go on. Let's do one more. And then we'll give you a little bit of time. Of course, you have all day and all night, right? To do your own if you'd like. Okay, so here we are, a different kind of equation for us to graph. Exact same process. First thing I want to do is find my vertical and my horizontal asymptotes. They will tell me a whole lot about my graph. Let's go with the vertical asymptotes first. Let me change to red. The reason I go with red is because those are excluded values. I can't ever touch those points. So my vertical asymptote, my VA, is whatever is excluded from the domain or the denominator. So if I do x plus 5 is equal to 0, I know right away that the value that x can never be is negative 5. So that's my vertical asymptote. So I'm going to come over here. I'm going to count over 1, 2, 3, 4, 5. And I'm going to put my vertical asymptote on. Right, here's my vertical asymptote. And I label it x equals negative 5. And then I'm going to calculate my horizontal asymptote. Excuse me. Now, my horizontal asymptote is found by analyzing top degree versus bottom degree. Okay, so I'm going to come back to where I have y equals x plus 2 over x plus 5. Now, the number one mistake is students automatically put a 2 over a 5. Right, that is not what I want. I need to first evaluate what their degrees are. Right, the top degree has a 1 and a 1. So my top degree is equal to 1. And my bottom degree is also equal to 1. So when the top degree is equal to the bottom degree, then it is always y equal the lead coefficient over the lead coefficient. And in this case, I only had a 1 in front of either one of these variables. So a 1 over 1 is my horizontal asymptote. So I'm going to say y is equal to 1 is my horizontal asymptote. So I'm going to come back to where y is equal to 1. That's right here. And I'm going to draw a horizontal line. And I'm going to make it broken just because it doesn't really exist. It's just a line that my graph is never going to touch. Okay, now I'm going to switch colors because the next parts are going to be part of my graph. So the next thing I want to find are my intercepts. Again, I think the easiest intercept for me to find is going to be the y-intercept. So I'm going to go there first. So the y-intercept, I'm going to let x equal 0. So I have a 0 plus a 2 over a 0 plus a 5. And so my intercept is at 2/5. So my x is 0, my y is 2/5. And if you want to know what that is, I believe that's about 0.4. Perfect. So I'm going to go back to my graph. I'm going to go to my 0, and I'm going to go up 0.4. Now, there's 0.4. So that shows me that the graph is going to be in between here. So it looks like it's going to be on this side, and I bet it's going to be on that side also. I do have a possibility for an x-intercept here. My horizontal asymptote is not y equals 0. So in order to find that, I'm going to take the numerator. And if you're not doing that, you're just doing 0 over 1 is equal to x plus 2 over x plus 5. If you cross multiply those, remember that this one becomes 0 is equal to x plus 2. And when you subtract 2, x is equal to negative 2 is my x-intercept. So I'm going to cross the x-axis at negative 2, 0. Well, negative 2, 0 is right here. Well, that's fabulous because now I have 2 points that I need for this graph. I'm going to go up just a little bit so I can have a little more room. And this is where I make my x and my y. Now, my excluded value was negative 5. That was my vertical asymptote, so I can never be negative 5. And that's what this vertical red line represents. I guess I should label too. I didn't label this one. So this one was your horizontal was y equals 1. And let me label this so we can see it again. It's x equals negative 5. Now the graph is going to be in those two quadrants that are not affected by the asymptotes. All right, so let's pick three values above. So -5, -4, -3, -2, and then let's pick or three that are smaller: -6, -7, and -8. Okay. I go back to my equation. I now have two variables to substitute in for. So here's my equation, the x plus 2 over x plus 5. So the first one I'm going to put in, let's put in the -4. So let's do -4 plus 2 over -4 plus 5. And that's going to give me a -2 over a +1. So when x is -4, the y is -2. All right, well, let's see what happens over here. If I go to -4, 1, 2, 3, 4, then I would be, oops, not at 2, I would be, erase, I would be at -4, -2, 1, 2, 3, 4, 1, 2. And do you see how it rounds the graph off a little bit? Now, I've already done the other one, so all I really need to do is go back and fill it in where they have been located. So I have a -2 and a 0. That was my x-intercept. And then my -3, I didn't have that point. So I have to calculate this one. So a -3 plus a 2 over a -3 plus a 5. Okay, so I have a -1 on top and a +2 on the bottom, which means I have a -1/2. Now let's see how close I've drawn this. 1, 2, 3 and a half. A little bit off, but not too much for my crayons that I play with here. Okay, so I've got half of it. Now on the other side, do you see that this one is 1? Okay, so it's 1 away from the vertical, and then it's going down 1, 2, 3. So 1, 2, 3, I bet you is going to give me the other side of it. So I'm pretty good at doing those guesses, but you don't have to do that. You can go back and just substitute in -6. So if I plug -6 in plus 2 over -6 plus 5, I get a -4 on the top and a -1 on the bottom, which would give me a -6, +4. All right, let's count it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. There it is. Okay, here's the next one. -7. -7 plus 2 over -7 plus 5. So I have a -5 on top, and then I have a -2 on the bottom. And negative over negative is positive, and 5 over 2 is 2.5. So I'm going to go to -7. So there's -7, and I'm going to go up 1, 2, and a half. And that's the one that matches this one. And then here's the last one. Let me go up just a little. So here's the -8 plus 2 over the -8 plus 5. All right, here's -6 on top, and this one is a -3 on the bottom, which will give me a +2. So my solution is -8, 1, 2. All right, and then here's the second branch of the graph of the rational. They do seem like they're quite a bit of work. I do understand that. They're not too bad, especially when you know that you've got this calculator that you can check things with. So let me put this one in and we'll check it. Now, here's the key. You do have to keep the top and the bottom separate by using parentheses. So if I put in an x plus 2, I'll close that to keep that on the top, and then divided by parentheses and x plus a 5, and close that to keep it on the bottom. When I hit graph, there you go. Looks pretty close to mine. Of course, it's a little more extended on the right. I just don't graph any more of it. I could. So there you have it, everyone. 2 examples for how to graph rational functions. You are able to use your calculator to do some checking. And your homework is this worksheet. This one is worksheet number 3. there is 2 questions on the front and 2 questions on the back. So you do have 4 questions to do for your homework. So if you have any questions on this graphing, feel free to let me know. I know it can be quite challenging to do this, especially by video. So I'm here if you need me. Just give me a shout and let me know what you need. Okay, have a great day. Be well, everyone.